Hello, my name is Felipe. Welcome to this presentation about Robotics Simulation Labs, where I'm going to share with you some of the experiences that we had with the implementation of Simulation Labs for a robotics course and discuss if it is a good alternative to teach robotics online or not. The Robotics Simulation Labs first. What are Robotics Simulation Labs? When I'm talking about Simulation Labs, I'm talking about the website that we created, which is a set of tutorials for practicing robotics concepts. It uses Python and Webots. Webots is an open source robot simulator that the RoboCup Junior also started using last year. And it was created to supplement my robotics course, which is an introductory level course on robotics, focused on robotics control for second year students of electrical and electronics engineering at the Hanze University of Applied Sciences in the Netherlands. Well, a bit of introduction of myself. My name is Felipe Martins. My background is in electrical engineering. I have a bachelor's, master's, and PhD in electrical engineering. PhD is focused on robotics. I have 4 years of experience working as an engineer in industry, basically with automation and a bit of electronics as well. I've been teaching for about 15 years, first for about 10 years in Brazil, and now more recently here in the Netherlands as well. And in this whole period, for almost 10 years, I've been teaching robotics for engineering students. I've been also a member of several technical and organizing committees of scientific conferences related to robotics, automation, and also robotics competitions, both in Brazil as well as internationally. So why did we implement simulation labs for robotics in the first place? As you can imagine, probably by now, the main goal was to replace the practical activities of my robotics course, which were canceled due to corona-related restrictions in 2020 and 2021, and well, maybe also in 2022, nobody knows yet. But before that, we used Cosmos, and Cosmo are those small robots that you see there, and they are very motivating to students because our students really enjoy playing with Cosmo. So we used the SDK from Cosmo in the past to have students programming controllers for the robot in Python. But we couldn't have that anymore, so we had to come up with a solution. So what is this robotics course anyway? Well, the robotics course is a second year course for electrical engineering. So it is a course of 4 credits, 4 ECs, 4 European credits. And the European credits are measured 4 ECs. That means approximately 112 hours of student work. So not 112 hours of lectures, of course. We have actually only 10 lectures, 1 per week, lectures of 2 hours, and then 4 labs, and at the end, 1 written exam. The learning objectives of the course specifically for the practical part include understanding the basics of mobile robot kinematics, so the modeling of the robot, especially for a differential robot, so hence we used Cosmo, and apply it to measure position and speed in a given application. It also includes applying concepts of control systems to implement a PID controller to control the orientation of the robot, and to understand the concepts to implement a trajectory tracking controller to control a mobile robot to follow a specific trajectory in a flat plane. It also, it's not mentioned there, but we also include a part where we discuss the implementation of state machines. So the simulation labs were created to try to replace the actual physical labs, and the structure that was created is the following. The first lab is just introduction to Webots and installation of everything, so it's like mandatory to start with the whole simulation. Lab 2 is basically a simple line following behavior with a state machine. Lab 3 is odometry-based localization, so it was required for the simulator to actually have these sensors for the robot to measure its own displacement. And Lab 4 is trajectory tracking controller. So all those 4 labs are basically the mandatory labs, but we also had Lab 5, which is the combined behaviors, or combination of all the behaviors to execute a more complex task for the robot that combines many of, that is divided in many steps. Lab 6 is an optional bonus kind of lab, which is to build a robot soccer team, and that was based on the RoboCup Junior soccer simulation that was introduced in 2021. I was a member of the team that actually implemented this. We had a demo at the beginning of the year, and then in the middle of the year, when the official competition ran, we also used it. So I give this as a kind of a bonus thing for the students as well as motivation. So all the labs, they are structured in a way to guide the students, because the idea here is that the students work very independently. So I'm not going to be guiding them anymore, of course. Then there is some structure described in the labs in the kind of tutorial self-study form. So there are always a description of the objectives, some background information with links for the students to go and read information that they need, including Webots tutorials for the implementation of stuff in Webots. Of course, the tasks that need to be executed by the student. And there is also, I provided also a template with some bare bones code, which means that, well, if the student has no idea how to start, then at least this, the idea is that this should help. But I managed to implement this only for 2 labs. And the solution code for 3 of the labs is also given. So this is just an illustration of how the web page is. The code is all in GitHub, so I use GitHub pages to build some nice looking web page there. So the link is also there. I'm not going to open it right now, but everything is available, and of course you are welcome to use as well. And please give some feedback. So just to give you an idea, this is one example of one of the tasks that the student needs to make. So the first one is a line follower state machine. Basically, I based this one an example from Webots that use a small differential drive robot to implement this state machine. This state machine that you see there is basically this state machine here is already implemented there. And this is to follow a line, but the task of the students is actually to convert this to Python code. So to start getting a feeling of first of all, how to implement a state machine, and second, how to actually put code there to make the robot work. So the code in Python is actually the code that the students need to implement. So how did the students actually like it? So first of all, we asked the students, do you have any prior experience in programming? And 80% of the students had no experience in robot programming whatsoever. And then we asked, how many labs have you actually tried to do? Most of the students tried 3 or 4 labs, so the labs that were actually more important. Some also tried more than that, but the important ones were the first 4 anyway. And but not everybody actually managed to complete all the labs. So they didn't have to successfully complete all the labs in order to pass the course. But the motivation was really to implement things in the lab because it would also help in the exam. So in general, how did they find it difficult or not? Well, 14% of the students found it too difficult. So they really were struggling. But you see here that, well, most of the students actually found it challenging, but actually doable, or some were easy, some were difficult. So all in all, yeah, about 80% of the students actually found it doable somehow. So we think that it's actually in the right balance between, well, being too difficult and actually being doable. So we managed to do that. Well, there is also solution code for some of the labs, and some students actually found it helpful, some didn't. And, well, most of them found the activities of the labs actually useful to learn the concepts discussed in the lectures. So we are glad with that. And very surprising, 76% of the students said that they would prefer to work with real robots. I was expecting it to be like kind of 100%, but apparently some students don't actually care. So some students actually wrote comments. We opened it for comments, and these are just the way that they wrote the way that they wrote the comments. I didn't edit it. So one student says physical education lessons are way better, and yeah, I can understand that. Other one said, if it is possible to have the practicum in a physical form with real robots would be great. Yeah. Get the code writing out of the exam. Oh yeah, because in the exam they had to implement some code, and they were complaining here about the exam then, because it's really irritating. You see some English problems there as well. But there are also good comments, like it was interesting to see and make a robot in simulation. I really enjoyed working with Weebots. I enjoyed it so much. Next doing the tasks, I also messed around with the program, seeing what was possible with it. And that is the kind of reaction we like to hear very much. Another student said, I think it's pretty good compared to any other online courses from YouTube. I could clearly understand step by steps, and that is very interesting to hear. Thanks for the helpful lectures. And real robots have some pros and cons. What I liked about simulation is that I could work all by myself and at home, and it always worked once you understand how to use the software. So that is a very interesting feedback that we got, and we are glad that we actually got to these students. So all in all, it was possible to cover the content and achieve the learning objectives using simulation. More than 80% of the students found the simulation helped. The level of difficulty was okay for around 85% of the students, and around 75% of them actually preferred to have the practice with real robots, of course. Many students did not follow the simulation labs, and the passing rate in the written exam was about the same as in previous years, so it didn't make any difference having simulation labs or practical labs. So, the first question, are the robotic simulation labs a good alternative to teach robotics online? Well, yes and no. Probably not to replace physical labs. It can work as an extra tool to give students more opportunities to practice, including at home. Students can test the concepts quickly and play with different robots in a safe and diverse environment. We plan to keep the simulation labs as a replacement of at least part of the physical labs, but combine it with the physical labs in the near future. Well, that was what I had. I hope this contributes with the discussion, and I hope to be there as well to discuss it with you. Thank you very much, and I'll see you.